Lesson 2-1, Integers and Absolute Values. So when we are looking at numbers on a number line, the negative number is a number that's less than 0. So we have these numbers over here. And then a positive number is a number that is greater than 0. And so we represent those on the number line. An integer is any number from the set -3, -2. So any number that goes this way from 0 or any number that's above 0, but they have to be whole numbers. So things like decimals like 0.5 or 1.2 or 1.3 are not considered integers. When we are writing integers for real-world situations, you can write the integers in word form by using words to describe positive and negative numbers. Some examples we might see for positive would be more than, increased by, deposit, above. There's some other things that I'm sure we'll see over the course of examples. Some things that you may see for negative numbers are less than, descends, loss, decreased by, below. Again, there's more examples. So here's just an example of how we would write it. 11 inches more than normal. So more than tells you that it's positive 11. So we're able to graph integers on a number line. To graph an integer, you locate the point named by the integer on a number line. When a mathematical sentence contains a less than or a greater than sign, this is called an inequality. We're also able to graph inequalities on a line, just as if we were graphing an integer. So here's an example of an inequality. -11 is less than -9. When comparing two integers, you place them on a number line. The number to the left is always less than the number on the right. So if we're looking at this example here, we have our -4, our -2, and our 3. So since the -4 is to the left of the -2, -2 is greater than -4. And so we can write it like this. So -2 is greater than -4, or you can write it that -4 is less than -2. Pause the video to try the examples below. Write two inequalities involving 1 and -2. So if we wanted to write this, we could write 1 is greater than -2, or you can write -2 is less than 1. The next one says replace the parentheses with less than, greater than, or equal to, -4, parentheses, -6. So we would replace that with -4 is greater than -6. The absolute value of a number is the distance the number is from 0 on a number line. The absolute value of a number is always greater than or equal to 0. So for the example of -4, -4 is 4 units away from 0, so the absolute value for -4 is 4. +4 is also 4 units away from 0, so the absolute value of +4 is 4. When we're solving expressions that contain absolute values, you want to simplify the absolute value down and then solve the equation. So looking at the example below, it says the absolute value of -4. The distance from 0 for -4 is 4. So that answer would just be 4. But if you're simplifying down the absolute value of -8 minus the absolute value of 5, you first want to get rid of those absolute value bars. So the absolute value of -8 is 8. The absolute value of -5 is 5, because again, it's just the distance from 0. And then the sign still stays the same, so it's 8 minus 5, so the answer here would be 3. Pause the video to complete the examples below. The absolute value of 8 is 8. The absolute value of -17 is 17. Now we have negative, which stays the same, absolute value of -7, which is 7, plus the absolute value of 12. Now we're adding integers. So if we have our number line and we travel over -7, 1, 2, 3, 4, 5, 6, 7, is where we are right here. And then it tells us that we need to go positive 12. So we 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that ending point there would be positive 5. We're also able to do absolute value and algebraic expressions in one. You first want to replace the variable, and then you want to simplify the absolute value, and then you want to solve. So for the example below, it says evaluate 6 plus the absolute value of 2. So the absolute value of 2 is 2. So this one is just 6 plus 2 is 8. Pause the video to complete the lesson review. Make sure that you submit your notes and your review for verification of this video.